Today we're going to continue working on proportional relationships and looking to compare them. The only difference in what we've done so far and what we're doing today is that the two proportional relationships are represented differently. So in example 1, we see that we have a graph for Ollie's Arcade and an equation for High Point Gaming. So step 1 is to find the constant proportionality. Remember that constant proportionality we use the letter K for. So if I'm looking at Ollie's graph and I'm trying to find the cost per game, that unit rate is always Y per X. We could also write that as the ratio Y over X, or Y divided by X. For Ollie's Arcade though, you notice at 1 hour, that is our unit rate. And if we look at that point, we can't tell exactly what the Y value is. So we look for a point that's in the crosshairs. We look for a lattice point. Here is a point where I know exactly what the Y value is. The Y value is 3 and the X value is 2. So when I go to create my fraction for K, that ratio, Y is 3, X is 2. We have an improper fraction, 3/2. That is equivalent to the fraction 1 1/2. But when we're talking about money, we would write that as a decimal. So 1 1/2 is 1.5, but since it's money, we're going to write that as $1.50. So the important thing to remember from the graph is they're called lattice points, but you're going to pick a point in the crosshairs where you know exactly what the X value is and what the Y value is. So here our unit rate for Ollie's Arcade is $1.50 per hour. For High Point Gaming, they give us an equation Y equals 2X. Now remember, for proportional relationships, the equation is Y equals KX, and in this case, we're looking to find K, so K has to be equal to 2, which means that the unit rate would be $2 per hour. And if you and your friends are going to the arcade and you are trying to get the biggest bang for your buck, then your best buy is Ollie's Arcade because it is a lower price per hour. All right, example 2. Example 2, we're comparing the sunflower's growth to a tomato plant's growth. Again, if we're thinking about our Y per X, our Y in this case would be the height in inches. X would be the number of days, so we're looking at inches per day of growth. Quick reminder, 0 days, there would be 0 inches of growth. Remember, for our K value, we are looking at our Y over X fractions. So we would have 1.25 over 1, that is 1.25. If we looked at 2.5 divided by 2, that is also 1.25. And 3.75 divided by 3 is also 1.25. So 1 1/4 inch, or 1.25 inches per day. Remember, this Y over X is our K value, so K is equal to 1.25. And when we go to write our equation, Y equals KX, that would be Y equals 1.25X. And for the tomato plant, again, we have a graph, so we're looking for a lattice point, a point in the crosshairs. So we could use this point, and if we're looking, our Y value is 3, our X value is 4. So when we go to create the fraction, Y over X for that ratio, our Y value is 3, our X value is 4, so we get 3/4. We could write that as a decimal if we wanted to, which would be 75 hundredths, or 0.75, which in this problem means that the tomato plant is growing 75 hundredths of an inch per day. If we were looking at which one is growing the fastest, the one that's growing the fastest would grow the most each day. So the sunflower is growing the fastest because it's growing more inches each day. So pause the video and try this problem. This problem, we are comparing the cost of strawberries to the cost of grapes to see which fruit is the cheapest. One quick thing that I want to point out is that on the cost of strawberries, they're using the equation T equals 2.5P. So what I want you guys to consider is that on our x-axis and our y-axis, if we were going to graph this, the number of pounds would go on the x-axis and the cost would go on the y-axis, because the cost is going to depend on how many pounds of that fruit that you buy. And remember, y is our dependent variable. So this equation is really the same thing, except for instead of using x, because on the x-axis was the number of pounds, they've replaced the x with the p for the number of pounds, and they've replaced the y with a t for the total cost. So pause the video, try and find your unit rate for both of these, write an equation for the cost of grapes, and then determine which one is the best buy, which fruit it costs less per pound. When you're finished working out, you can play the video again to see if you were right. Okay, so for the strawberries, for our equation y equals kx, remember the k is our unit rate. And so in this problem, k is 2.5, and so the unit rate is $2.50 per pound. For the cost of the grapes, remember that ratio is y over x, so we could have $3.70 divided by 2, which is $1.85. $5.55 divided by 3 is also $1.85, and $7.40 divided by 4 is also $1.85. So my K value is $1.85. My unit rate, $1.85 per pound. My equation would be y equals 1.85x. And again, we're trying to answer which fruit costs less per pound, which would be our best buy, and that would be the grapes, because they cost less for each pound. They're the cheapest fruit per pound. All right, now you guys are going to be working on a practice sheet. I want the practice sheets finished and turned in, and then you guys are working on your IXL end skills. Remember, those end skills, you're going to work up to 50 and then move on to the next skill. Stay on task, keep your computers on the right screen, do right, and I look forward to getting a great report from the sub. Have a great day, guys. See you tomorrow.